Okay, I lost the audio for a second. So to find the range, we can just take those f of x, g of x functions in terms of x and plug the 0 to 1 interval that they gave us and find the y. So we have the math for that over here. So our range for y is from 1 to 2. So that is a range for in terms of y. And here is the washer method of the functions. So the washer functions, or the washer method for this region that we're trying to find the volume of, this is the equation that you use. It's the outer radius minus the inner radius, or the larger one minus the smaller one, times pi. And well, it'll be horizontal slices, because for washer method, it's always perpendicular to the line that it's rotated about or revolved about. So because it's revolved around x equals 2, we have to take horizontal slices. And so, like I said earlier, because we have that gap between x equals 2 and where the function starts, we have to take 2 minus the outer radius and then square that and then subtract that from 2 again minus the smaller radius squared times pi. And that is how you find the washer method, the volume of these functions using the washer method. And so just writing these equations from below, this is our equations in terms of y, because we have to use horizontal slices, therefore it has to be in terms of y. And so, like what I just said, this is just written down of what I just said. So just to make it more clear as well, our outer radius is going to be that x squared plus 1, and then the inner radius is going to be that square root of x plus 1 as well. And that is what we get the equation. And so moving on, we'll look at the shell method. Shell method is a whole lot easier because our our functions were already given to us in terms of x, and we don't have to change anything. It doesn't have to be two integrals, because we don't have to change anything. We just have to plug stuff in. And so that is why it's a whole lot easier, because with shell method, it's always parallel to what line the functions are being revolved around. And so because it's being revolved around x equals 2, we can easily take vertical slices, as you can see here. And so these are our functions again, just to remind us that this is our range, is from 0 to 1. And this is the formula for the shell method, 2 pi x, which is the radius times the height, which is f of x dx. And so also, yes, okay, so this is our radius and this is our height. And so I'm just trying to show that, because just like we had to do for the shell or the washer method, we have to do for the shell method as well for the radius, because we have that gap from the line that it's being revolved to where the radius is. We have to take 2 minus x to find the radius. And then we also, for the height, because it's going to be vertical, that top function is that square root of x plus 1 minus the bottom function, which is that x squared plus 1. So that is our height. That is our height from, as you can see, the vertical slices from top to bottom. Same thing, our height, that is our height, and our radius. So 2 pi times 2 minus x times square root of x plus 1 minus x squared minus 1, distributing that negative times dx. That is our shell method. And it's a whole lot easier because you don't have to change anything. It's already set up as well because it's being revolved around the line that works best with the method. And so this is me solving for the volume. A lot of math, and so we have the grand total of 31 pi over 30. And that is the end. Thank you